Good day to everyone. This is Engineer Danny Domingo. I will be your presenter on this topic, structural analysis and design using advanced softwares, a 6-story building application. For the contents, first we have a brief project introduction, then typical architectural and structural plans presentation, design criteria, analysis and design softwares, its inputs and outputs, then design ratios. For the brief project introduction, it is a 6-story residential building located in Santa Rosa, Laguna. The client is a AAA developer in the Philippines. The site is in the Philippines, here in Southeast Asia. Now, the exact location is a bit at the southern portion of Manila. This is the capital of the Philippines. It is in Santa Rosa, Laguna. Now, for the typical architectural and structural plans, the ground floor of the building is an open parking. Therefore, column must be minimal and wide openings should be provided on the entrance and exits of the ground floor for the cars. And this is a typical third to fifth floor plan of the building. The elevator is at the middle or at the center of the building, and there are two fire exits located on the left, on the right wing of the building. Take note on the elevation that there are big window openings for ground floor ventilations and openings for cars and car entrance and exits. This is the rear elevation. Very similar to the front, there are wide window openings and car entrance and exit openings. This is a typical structural framing of the building. Now, during the scheming part, we were able to convince the architect that we need to avoid soft story to be developed on the ground floor against seismic earthquake loadings. We were able to convince the architect to make us use of the stairwells as as a shear walls. Same thing with the elevator shafts to produce stiffness and rigidity on the buildings against earthquake loadings. For the design criteria, design code shall be the National Structural Code of the Philippines, Volume 1, 2015, and all of the material structural properties and the design loads should conform with the NSCP 2015. The concrete that will be used shall be 4,000 psi for the beams, girders, and columns, and 3,000 psi for the foundation. For the reinforcing bars, we will be using high-grade steel. And for the ties and spirals, we will be using intermediate steel at 40 KSI. For the structural steel, it should be grade E36. And for the purlins, we will be using cold formed steel. This is a typical design dead load, no? Or in accordance with NSCP 2015, Section 204. The slab thickness is 100 mm at 2.4 kilopascal. We have here the loading for the ceiling, the partition, the MEPF stairways, and the roof load. For the live loads, we are using the 1.9 kilopascal equivalent to around 40 PSF for the residential portion. And as all of these are in accordance with the NSCP 2015 again. For the wind loads, it is in accordance with Section 207, considering basic wind speed of 270 kilometers per hour or 168 miles per hour. That is in accordance with the wind contour map of NSCP 2015. For the seismic load, calculation, one thing that you will notice is the distance of the project site from the fault line is only 870 meter. So that's a bit close to the uh, valley fault system. This is the closest fault line, active fault line from the project site. Okay, again, for the information of everybody, valley fault system is the major fault line that is crossing Metro Manila from San Mateo area, the West Valley Fault, runs round south towards Santa Rosa at the end portion of Silang Cavite. Now, if you take a closer look of the site, okay, this is the valley fault system. Here is our project site. So you can see that it's only about 800 meter plus the valley fault system. Now for the purpose of this presentation, we will be using two softwares, Midas Gen 2020 and ProtaStructure 2021. Again, this presentation is not a software tutorial. The objective of this presentation is to illustrate how we applied the use of these two softwares, particularly in this project. So let's start first with the Midas. Using Midas, this is how we modeled it. Basically, we input the coordinates of each nodes of the structure, okay, using different technique in Midas. Okay, that is the input routine using Midas. Then that is the how we input the materials, the building materials using Midas. So you input if it's concrete or and also the grade of concrete. Okay. Now this is how we input the section per element. That's okay. This is a 3D view, perspective view of the model. You can see here the shear wall of the elevator shaft and the shear wall at the stairwell on both wings of the buildings. This is how we applied the loads. The floor live loads are applied are this. For the one-way and two-way slab, we just pick the corners of the floor frame to input the loads. Then for the wind load, you need to input the load code, and for NSCP 2015, we are adapting the IABSE 2012 right now. We input also the wind speed, the exposure, the mean roof height, and other wind parameters for the calculation. This is the diagram showing the wind load distribution per floor of the building. For the seismic load, the same thing. You will have to input the seismic load code. Right now, NSCP 2015 adopts the UBC 1997. So you have to input this parameter, the soil profile type, the seismic zoning, source type, seismic source type, distance from the nearest fault line, and other seismic design parameter like the ductility coefficients. Then this shows the seismic load distributions per floor of the building. From there, the software can generate its analysis, calculating all the shear forces on the beams. Okay. And after that, we can start design of each element For this, it shows the Midas output. In beam design, it generates the number of reinforcement at the top, at the bottom, for the left support, right support, and at the midspan of the building. Then for the column, okay, this is how the design output for Midas looks like. The design ratios are given in the calculation. Same thing with shear wall. It shows the design ratios for this specific thickness, and this it gives the required reinforcing bar layout. Then Midas then can generate the total weight of concrete, and in turn we can calculate from the weight given. Knowing the unit weight of concrete, we can compute for the total volume required for the basic frame elements such as beam, column, and shear walls. Then we use another software for this particular project, that is STRUCT-CHANNEL 2021. Later on, I will discuss to you why for this particular project we found it efficient also to try using this structure. That is the model generated by structure. You can see there the shear wall highlighted. Now in structure, you need to define the grid lines. That is the main difference in Midas inputs. Then this is how we input the materials. Okay, that is the environment in Prota. Now these are the routine. This is the routine on how we input the dimensions of the beams, the columns, okay, using this section element routine of Prota. Then this is how we define the floor load. Okay, this is the input routine in Prota where we input the design floor loads for both the live load and the dead loads. Okay, then it's quite very similar to Midas where we input how we input the wind loads. You have to input the design parameters, no? The basic wind parameters. Okay, for wind loads. Same thing with seismic. You have to input the basic design parameters such as the zoning, the distance from the default line, and other parameters. If you have to do the dynamic analysis, this is how you input it in Prota. But since this is a regular structure and only 6-story, we did not do any dynamic analysis for this particular building. And after the inputs, Prota can generate the analysis, the shear and moment diagram for each member, the stresses, the shear and moment stresses for all the beams and columns, and also for shear walls. Same also with Midas. Now for the design, this is how Prota do the design. One good thing with Prota is that you can see the bar layout on its longitudinal section. Okay, you cannot see this kind of output in Midas. Okay, this is the sample of a concrete design using Prota. Okay, you can see there the stresses on the column, the design moment, and the design axial load. And at this part, you can see here the design the actual design requirement reinforcing bars for that particular column. Okay. After that, we can design the shear wall. So the reinforcing bar layout, the thickness will be considered. It is integrated in the analysis part of the software. Now, one thing good with Prota is that it can generate automatically the structural framing. Okay. So this is in CAD DWG format. So it can be exported to your CAD standard CAD drawing title block. So no need to encode all these details one by one. Okay. And using this the drawing part of the Prota, we were able to generate the bar cutting list of the beams. Okay. So the highlighted thick lines here gives us the design locations of longitudinal reinforcement, and it is tabulated here. So it can be generated also in DWG format. Likewise, it can generate the column schedule from the lower floor going up, giving us the column tie layout with the column dimension. Okay, and the cutting list for the columns. Then the splicing for the rebar can also be generated. The bar cutting list for the column rebars can be generated. And for the estimate, the Prota estimate part can generate the total weight of reinforcing bars needed and the cutting list. Now, I just like to warn that Prota bar cutting list is only for the purpose of doing a good estimate of the kilogram, no? Because the software only use one source length. For example, if you input the source length to be 6 meters, it will only use a 6-meter length rebar, source length of rebar. In the industry, for the interest of the contractor, to minimize wastage, usually in preparing their bar cutting list, they use all the 5 available, commercially available in the Philippines, which is 6 meter, 7.5, 9, 10.5, and 12 meters. Okay. So this is still good as far as the initial estimate of the rebar. Now, just to give you a comparison of output between Midas Gen and Prota structure, the left side of the screen you can see the dimension generated by Midas 350 by 500, which is the same with what we got from Prota structure. Same thing with the reinforcing bar at the left, 320 millimeter, and for Prota we also get 320 millimeter. Okay. So it's the same. It should be the same, no? Same thing with the column. We get the same sizes, 500 by 800, and the same number of bars. For Midas Gen, 1425 millimeter diameter, and also 1425 millimeter diameter using our Prota structure. And for the shear wall, both the both Midas-Gen and Prota yields 0.35 thickness of shear wall with the main reinforcement at 20 mm diameter spaced at 125 mm diameter. Okay. So basically the design is very similar. Design ratios. This is the main reason why we in this project, our team experimented in using two softwares. We acquired Prota software last year 2020 during the pandemic because we have so much time to experiment, to study. Okay. Now, the items at the left are the items usually used by developer client as benchmark in our design for them to gauge if our design is economical. So, the first one is what we call the concrete ratio. It is a total kilogram or the total volume of concrete in cubic meter per floor area. So that is in cubic meter per square meter of development area. And usually in our previous project, for a 10-story regular building, the client benchmark was 0.45 cubic meter per square meter of floor area. For this particular project, we were able to generate a 0.38 concrete ratio. So, it is between or lower. It is lower than what the client expect at 0.45 cubic meter per square meter. And for the RIBA ratio, which is 150 to 200, the client benchmark is 150 to 200 kilogram per cubic meter of concrete. Okay. In this project, we were able to generate 166.10. So it's between 150 to 200 kilogram per cubic meter. For the form system, the client benchmark is 1.5 to 2.5 square meter per cubic meter. So we were able to get 1.86 square meter per cubic meter of concrete. Now take note that this parameter here doesn't say that your design is safe or not. It is not general on all type of building. All depends on the building irregularities. If your building is irregular, either horizontal and vertical, you may not be able to meet these design ratios. So the thing is, we must be able to reason out the rationality to our client, to our architects, partners, why we cannot get those benchmark. As a structural engineer, we always have our option to say no to these design ratios as long as we were able to do our job in our calculation. So we are not promoting any software here. Okay, our presentation was just an application in our team because the objective for us is to generate the design ratios, the estimate. Aside from doing the correct design using the software, we have to generate the design ratios as quick as possible so that we can gauge if our design is within the expected output by our client. With that, thank you very much for listening. If you have further questions, you can contact me at my email below and our office landline in Quezon City, Metro Manila, Philippines. Thank you very much.